Hello everybody. Today I'll be telling you about a design principle in viral proteome, and that will be a poster presentation on this topic. So let's get going. What's so special about viruses? Okay, we know quite a lot this year about them. They are all over the place, extremely diverse. They are critical to human health, of course, and they do have a different evolutionary rate, which a lot of their function indeed depend on their host. So the idea of this poster, of this research, is to seek design principle which apply to probably many or even all viruses across the world. So few words about the viruses. How can we count them? So in principle, they are divided artificially to 7 groups by their replication format and DNA or RNA in their genomic information. Altogether, there are about 130 families, but of course, if we talk about the proteins, we talk about 10,000 reference proteome, and they account for over 5 million sequences in the database. So the poster talks about codon optimization, about a showcase for stealing of DNA and material, and about duplication and piling up. Let's get going. So the first design principle talks about optimization. What I mean by that? We know quite a lot about how translation is modulated by being fast and efficient, and we know that viruses do have to change the state of the cells in order to do some resource management, namely to shut down the host translation and to be able to do their own. So is there any preferred translation rate that we can follow? And this is, of course, take us back to the genetic code. So in very naive way, we can say the translation speed has 2 versions. One is a low abundance tRNA, which provide slow codon, and the other are high abundance. And the question we want to ask, whether the viruses are indeed choose their codon to be fast or slow. And to do this, we decide to look at all human infecting viruses, 500,000 of them, and we were able to divide them into 4 groups. The majority are uncharacterized protein, but the rest are 3 colors group. Pay attention to the blue one, which are the capsid, which are the only one that you need a lot of version, a lot of high copy in order to produce a virus. And indeed, we were able to show that the high production, the blue one, are having high adaptation, and indeed they are using the codon that are adapted to their host. So this is one very important principle. The second one, can we show something about stealing? And indeed, in order to do this, we ask the question, is there any evidence for viruses that are stealing from their host? And we did this a couple of years ago, in which we were able to show that it's quite common. Actually, it's not rare at all. There are over 2,000 such proteins, and they account with over 300 PFAM domain with a strong evidence for stealing. So what they steal? Here is a beautiful example of stealing of IL-10. IL-10 is a very important protein, a cytokine, and anti-inflammatory that are doing a lot of good things to our body, and we can see in this multiple sequence alignment the effectiveness of this stealing. And actually we were able to show that this stealing is really refined, because once this material is stolen, it's become to be better. So hundreds of cases of viruses stealing from the host. The last point is really going back to giant viruses, which show how they use duplication and piling up. So what you see here is giant viruses that have really not only 400 but 800, more than 1,000 proteins. This is a new growing family. Just to put the coronavirus in the corner, it's not a giant virus, just to show that we are talking about a different scale. And they have very many big surprises, but the most important one is their size. And we were able to show that if you look at their protein, at their proteome, you can find that they do have, look at the bright colors, many duplication. These duplication are many types of repeats, and this is just one example in which you can see that the number of ANC repeats in the proteins of a specific virus is really in the hundreds. And the idea that we would like to suggest is the idea is that the virus wants to get bigger, namely to reach the size of a bacteria so that it can induce phagocytosis by its host. So to wrap up, I wanted to show you that viruses are changing. As we know, this is just a coronavirus as a reference. And we know that they do have strategies for optimization, either by effective translation, and they do have more tricks. Thank you very much, and I think I'll stop here. בסדר, יאללה, סגרתי. מה, אתה לא מבין מה הולך פה. אז לא... זה ממש לא... את זה? גנבתי מלמעלה. היה אחד מיליתי אותו באדמה של חשמל, הוא עזר לי לגנוב את הדברים האלה. יש פה כמה. עכשיו רוני תעשה לי כל מיני כאלה פה. הולך להיות פה משהו שווה. אבל גיליתי את חשמל קצת. זה היה נחמד, דווקא שבילינו. הבאתי לו את האוכל, אז הוא ככה שמח מהאוכל.
הביתה?
כן.
זה קצת מודבק כל הספר הזה.
כן?
לא, נגיד ההרצאה האחרונה, אני מכיר את שמו, הוא מאוד טוב, הוא צרפתי. וזה מאוד מאוד ספציפי, בתחום שאני לא...